Dear colleagues, in our research, we pay detailed attention to various components of the professional competence of future software engineers. And the next stage is to study the problem of the forming competence in software design. Let me present the result of this study. A review of software engineering educational programs available at Ukrainian higher educational institution websites shows that software design training is accomplished in three main ways. Artificial introduction of design elements in different courses in close connection with the tools by the example of solving typical simplified problems on a certain industry. Spontaneous teaching of design elements during the internship on real tasks. Training on software modeling tool, usually UML. Only a small number of educational programs have attempted to take into account the global experience to design training organization based on synergetic combination of academic and industrial forms and methods of training. For some, the purpose of our study is to provide a historical and generic review to software design training practice of future software engineers. Modeling and analysis can be considered the basic concepts of any engineering discipline, and they are important for documenting and evaluating design solutions and alternatives. Serhiy puts a number of questions about what software design is. Can software design be defined using an engineering metaphor? For instance, design of a bridge must comply with appropriate laws of physics, but design in software has no laws of any kind to abide by, at least in theory. The most serious difference is that once construction commences, changes to the specification of an engineering product may not be allowed whether changes to software requirements are generally expected and can indeed happen anytime during the software life cycle. Can a computer program itself be considered a piece of art? It probably can, but not always against the same set of criteria. Can software design be defined by design activities? In fact, design activities are diverse. Many are certainly technical, yet some can be social too, but none is likely to be standardized to characterize design of its process. Can software design be defined by design artifacts to be produced or design phases to go across? The way to describe a design and document information, content and organization can range from the more traditional big design upfront all the way to the code is my design. In fact, a Gale practitioners believe that design is not only highly iterative, but emergent, and models often lie. Thus, only coding, running tests, and refactoring the code reveal the truth about a design. As a result, Serhiy defines software design as a systematic, intelligent process in which designers generate, evaluate, and specify concepts for a software system whose structure and function achieves clients' objectives and user needs, while satisfied a specified set of constraints. The design process is both extremely creative and extremely complex, so it is not surprising that there are few truly understanding designers. However, the demand for new projects is very high. And to face it, each architectural and engineering industry has developed a set of principles that enable designers with average abilities to create design solutions of acceptable quality. Although software engineering is much younger than other engineering fields, it has also accumulated some knowledge of how to create projects, and future software engineers need to master this knowledge. So design teaching should be an integral part of their training. David Weiss in presents experience of design software teaching in variant to the applied design methodology. His approach involves two stages. First, students are introduced to the principles underlying the methodology and the experience of applying these principles to small, well-defined tasks. In the second stage, students are offered a real task that they must solve independently and in a simulated work environment, receiving guidance on the methodological issues. David Weiss provides the following recommendation for the organization of software design training. Students must be advised by a design specialist who can ensure strict adherence to the methodology. The design task must be quite complex and students are not allowed to simplify it. Students should be encouraged to make their own project discussions. None of the teachers should interfere in the discussion-making process. The size of the students group should be small to allow teachers to closely monitor the progress of each student. Computing Curricula 2020 defines the following competencies related to software design. Present business discussion makers, architectural significant requirements from a software requirement specification document. Evaluate and compare trade-offs from alternative design possibilities for satisfying functionally and non-functionally requirements. And write a brief proposal summarizing key conclusions for a client. Produce a high-level design of specific subsystems that is presentable to a non-computing audience by considered architectural and design patterns. Produce detailed designs for a client for specific subsystem high-level designs by using design principles and cross-cutting aspects to satisfy functionally and non-functionally requirements. Evaluate software testing consideration of quality attributes in the design of subsystems and modules for the developer. Create software design documents that communicate effectively to software design clients such as analysts, implementers, test planners, or maintainers. The core of knowledge about software design, Serhiy proposed to divide in two categories: design process knowledge and knowledge of design enabling techniques. The latter includes design patterns. Serhiy and Tao considered modeling to be a central component of the quality software development process. The authors identify the following key concepts: modeling, the process of certain an abstract graphical or mathematical description of the design problem, during which the developer replaces a complex and detailed real situation with an understandable model that reflects the essence of the problem. The evaluation of the model in the iterative process of development tends to preserve the form of representation, while the transformation of the model involves a change in the point of view from which the design problem is considered, and a change in the structure of the design model. Code refactoring is the process of changing the code of a computer program in order to preserve its ability to develop, improve its reliability, or simplify the structure, while maintaining existing functionality. Refactoring training not only gives students practical programming skills, but also helps them understand the most important principles of software engineering. Design patterns can help developers solve certain design problems, as well as improve existing projects. Design pattern provides a conceptual model of the best practice solution, which in turn is used by developers to create a concrete implementation of their task. The use of design patterns has a number of advantages. The pattern provides a guide to best practice. The use of the pattern provides developers with a common dictionary for easy and clear discussion of complex design concepts. Due to this and other advantages, design patterns are often studied in software design courses. Chad Williams and Stan Kurkovsky amplifies that the process of learning to the appropriate software design patterns can be made creative by transforming the design process itself into a constructivist learning environment. To do this, they propose not to limit the subject of student projects and creative conditions for students to get out to get out of the comfort zone by applying new hardware platforms and interface to them. The interim evaluation of the project was performed according to the level of expediency and the number of used design patterns, and the final according to the level of creativity of the whole project. The authors propose a three-step process of learning design. First, students are asked to design their program using object-oriented design. Using the formulation of the problem, students are encouraged to object-oriented thinking and use a previous experience to create objects, classes, responsibilities, relationship, methods, and other UML entitlements. Next, students are asked to rewrite the program using design patterns. One of the patterns is the model view controller pattern. Finally, students are asked to adjust the use of the design pattern according to the chosen framework. Andrii et al. Offer a methodology that will give students the opportunity to take advantage of the framework into implementation of their project. Paraphrase the problem statement and extract all the nouns and verbs from it. The nouns serve as candidate objects, classes, and attributes, while verbs serve as responsibilities. Merge the extracted nouns into classes. This may require discarding irreal nouns or nouns representing the same thing. Merge extracted verbs into classes instead and responsibilities. Assign responsibilities are in defined required methods to complete those responsibilities. Walk through the scenario to ensure that each scenario is supported by methods and identify the collaboration between them. Design is an inherently and interdisciplinary subject, influenced by a large number of human factors. So teaching design is not only a process of teaching design itself, but also a process of future developing students' social skills. Stanislav Yazabek notes that team-oriented project courses provide an opportunity to learn the principles of software engineering when their application is really necessary and profitability, and suggests the following classification. Industrial attachment, in which students work on real-world problems in industrial settings. Project course is which students work on problems in various application domains under supervision of faculty members, experts in a given domain. Sometimes such courses build on a real-world problems provided by industry. Project courses in which students learn advanced software design principles and apply them in their projects. As faculty members need to scrutinize and detail design artifacts to provide feedback to students. Such projects might be supervised by faculty members specializing in software engineering and well versed with problem and solution domains students work with. Projects developed from scratch versus projects in which students extend existing software. Projects based on the specific software platform, such as .NET service, mobile device, or Facebook. Murtagh and Hamilton Jr. describe the organization of project-oriented learning, determining the following desired learning outcomes of students. Students should use the knowledge of previous computer science courses to develop moderately complex computer projects based on clear, consistent, and reasonably complete requirements presented by the teacher in the project task. Students must develop high-level architectural projects of programs and their interfaces and obtain the approval of the teacher before moving on to detailed design. Students must demonstrate that all requirements for the project assessment have been allocated to specific parts of the architectural design. Students must develop a detailed non-architectural project of software and all interfaces and obtain the approval of the teacher before embarking on implementation. Students should develop a test plan for each project. The test plan should demonstrate how all software requirements will be tested and include a software testing schedule. Students should develop documentation that show how their software and test plan meet the requirements of standards. Jan Warren methodically substantiated the learning outcomes of software design training. Identify and describe the objectives of software design. Design objectives include the correctness, robustness, flexibility, reusability, and efficiency. Students should appreciate that software should not only be correct, but that the latter for non-functional objectives are also important. Interpret and construct UML models of software. The UML, being the standard industry notation, is an obvious choice for communicating design knowledge. Essentially, students should be able to read and write UML models. Explain the notion of design patterns and describe a subject of patterns. Design patterns embody prone design solutions. Students should appreciate that using pattern fosters an engineering approach as opposed to one that solves problems from first principles. Apply patterns to solve real-world problems, making systems trade-off when necessary. Awareness of patterns is important but is not obtained for being able to apply a pattern to solve a problem. This objective is considered with deeper functioning knowledge. Apply newly acquired and developed programming skills. Students have functioning knowledge of fundamental OOP but have limited knowledge of Java class libraries and more advanced aspects of programming. These objectives aims to equip students with stronger implementation skills. Work with reality large software projects. Similarly, students' experience of development software is typically confined to small programs involving a few classes. Exposing students to larger projects is good preparation for final year project work and industrial practice. John Whittle and others offer another alternative to traditional learning, studio-based education, which brings to the forefront reflective practice as a way to develop design skills. In the studio, students are invited to critically reflect on their own and others' design, using a variety of techniques such as mentoring, design criticism, material mentoring, and considered evaluation. Software design experts, for example, Martin Petrie and Andrii van der Hoek, used informal modeling to summarize their own design experience. The combination of informal and formal modeling is possible with the help of flexible modeling tools, which after creating an informal sketch provide an opportunity to move to formal modeling without changing the tool. Petrie and Hook recommended the following action for reflection in software design. Do not allow deviation to minor issues when discussing the project. Regularly check yourself. When am I and what I am doing? Based on the deep understanding and the fundamental concepts of design, keep up to date. Remember what design discussions have already been made, why then were so, and what other discussions need to be made. Thinking about what is not designed, identifying and considering design limitation, to identify the design exceptionally or inefficiency. Periodically stop to look at the project as a whole, asking yourself whether the goals of customers, user perceptions, the market itself, etc., have changed. Anticipate different options for the future, analyzing the economic feasibility of determined where to invest in methods, tools, resources, design alternatives in order to save efforts in the future. In a study of design, Chen Hu recommends to consider the following. Students' technical competency and cognitive strength can significantly impact affect the outcomes of learning design. For relative small-scale design problems, test-driven development renders opportunities to express modeling ideals directly in code, allowing more effective evaluating to design trade-offs and committing less design errors than using diagrams. Learning small-scale design, writing related methods, appropriate data encapsulation, using good methods names, etc., is probably much less challenging than studying design in general to study structural stability, which requires design compromises and applying knowledge to the design process. The minimum basic design skills with an appropriate level of project thinking that graduates must acquire may include the ability to effectively begin design, decompose a task, perform design iterations with sound design compromises solutions, and implement the project in code. Students cannot effectively acquire the ability to design and learn project thinking if they do not solve design problems of appropriate complexity. Despite the lack of universal formulas or design recipes, data analysis, identification of entities and their relationships, and process analysis, detection of action and logical flows, is critical to understanding what information to use and how it is transformed. Correctly documenting a design, timely, not post factum, is a necessary skill. However, whether students should use UML or how correctly they use the language to the document the model is not so important. It is advisable to acquaint students with some classical diagrams, encourage their creative use. For the final assessment of students' learning outcomes, it is advisable to combine traditional classroom tests to make sure they know this with complex design homeworks which must be solved individually or in teams or two with careful monitoring and evaluation of finished design products made by students, but also the quality of project implementation documented in student report. Summarizing the results of the study has provided an opportunity to draw the following conclusions. Software design is a type of engineering design which combines two components, creative and systematic technical. In teaching software design, special attention should be paid to supporting students in design the theoretical foundation of which are acquired in the form of lectures, in the form of practical classes, studies, courses, projects, etc., to solve real problems of complex software design. Software modeling plays a key role in this successful design. At the same time, compliance with the requirements for the use of accurate formal uh, description of model in the design process does not significantly affect the quality of design. The transition from architectural design based on the chosen pattern to non-architectural detailed design may require adapting the pattern to non-design realities in the form of software design tools, such as the framework. Assessment of the formation of the competence in software design involves testing individual knowledge and team skills of design in the process of solving a complex design problem. Design artifacts such as sketch designs, formal models, design documentation, prototypes, and more are important for this. Therefore, the difference of projects is an appropriate from of evaluation. Prospects for future development of this study are too substantiated. The third, after requirements engineering and design engineering, engineering component of software engineering, software construction. Thank you for your attention. I will be happy to answer your questions.